First of all, thank you for the last presenters, for the very engaging interview style presentation. One of the questions that you asked, one of them was about ethics. Well, yes, and the ethics was defined being nice to at space. So, but unfortunately, we cannot say that everybody are nice today towards space technologies. I will bring you maybe one example that is was quite recent in Estonia. One of the Russian research vessels were found in one of the Estonian ports. And, well, it was found in international marine infosystems. When the officials went to check it out if it's there, the research vessel that shouldn't be, it was found out that it wasn't. So the GPS signal was spoofed. It was, well, not a pleasant joke towards us. So this is one example how you can play with different kind of data. And also in the morning we had also a really good keynote speech where several different examples were brought about the cyber attacks towards satellites like Starlink. Also one of the questions that were answered was, are you concerned about cybersecurity in space? And most of you were very concerned. So this is a really good topic that we are today talking about. So I would like to introduce you Sandhra-Mirella Valdma, who is going to give you right now a presentation about Cybernetica and an exciting project that they are doing with ESA. And afterwards, we will sit down and have a few words on the topic as well. Please.
Thank you. So basically, I had the lucky straw. I have the opportunity to give you an actual small talk about the project we are doing because there aren't other panel members here. So you will hear about our project called ShareSat. Firstly, I will talk a bit about our company, and then I will talk shortly why we are doing this project and, of course, how we are doing this project. So, Cybernetica, probably some of you know us, some of you don't know that much about us. Our main goal is to develop future-proof technologies for secure digital societies. So basically, the whole Cybernetica is quite big, and the space domain is only a small part of it. We were established some time ago in 1997. Our original roots are in academia. Maybe you have heard in Tallinn there's Cybernetics Institute. So there are our original roots. And as we do lots of R&D, there are quite many of our employees who have PhD. Currently, Cybernetica has almost 250 employees already. So in Estonian wise, we have grown quite big lately. So when I'm now talking about what we are doing, we have been the one who developed the first e-voting system in Estonia. We have developed different governmental technologies for several countries. One of the biggest one currently is in Ukraine. And of course, probably most of you have used Smart ID, so the technology split key behind it is actually developed by us. And as I said, our wide range of technologies starts from digital identity and ends in border surveillance. Where I work is basically in privacy enhancement technologies, where this project I'm talking about quite soon is located. And why is Cybernetica special is that compared to other private companies, we actually have an in-house research institute, which is actually accredited. If we want, we could give out PhD degrees. So we have actual researchers working in-house. We have PhD students working doing their degrees in Estonia together with other Estonian universities. We have several projects with, as mentioned, with the European Space Agency, European funds, EDF, NATO, and DARPA. Actually, origin of this ShareSat project I'm going to talk about originated quite long time ago. It was in 2013 when DARPA came to us and asked if it would be possible to use one technology to calculate satellite collisions without actually sharing the original orbital data of those satellites. Back then, we even published an article about it in 2015. Probably the world wasn't that ready for us, so because of that, we haven't found any other opportunities in the meantime. But fortunately now, finally, this year in January, our project together with the Estonian European Space Agency started, which is ShareSat. So, why we are doing this? As already mentioned, there are lots of space debris, lots of payload launches lately. As you can see from the graph here, the launches during the last, let's say, 10 or 5 years have grown rapidly. There are so many number of objects flown into space. There are lots of payloads. Most of them seems to be communication satellites. As you can see also from there, most of those are actually constellations. Already mentioned, one of the most famous companies actually sending out those is SpaceX Starlink satellites, who have a quite wide range of those satellites listed here. So, because when we have lots of new satellites, of course, the probabilities of them colliding between themselves or between the space debris increases. So if we would have no further launches, then still the probability of catastrophic collisions would increase. But if we would have similar extrapolation of launches, then you can see actually the probability of catastrophic collisions is increasing rapidly. And here's just also a short graph to overview how many different debris objects actually there are in space. Most of them are actually quite small. If you look, there are objects that are below 10 centimeters, I would say most of them. And now, why you don't want, or why do you want actually to share information between satellite owners? Because one collision could produce hundreds to thousands of different debris objects. So in history, one of the most famous events actually is collision between Iridium-32-3 and Cosmos 22151, which is one of the biggest clouds currently orbiting the Earth with lots of debris. But here also there have been several close approaches. Here I have listed one of the most notable ones between different satellite owners. What is a close approach? It means that actually one member, one operator has to do something so that two satellites wouldn't collide. So what we want to do is that mitigate the risk of those close approaches or mitigate the collisions at all. And what there is that, as I mentioned, there are loads of satellites sent out by Starlink. There are lots of maneuvers they have to do. They actually, because of that, have increased their collision probability threshold, so they maneuver more often than other satellites, which is somewhat good, because now they have less probability colliding with other satellites. And now going to collision avoidance. There are lots of different companies, private governmental sector, offering the solutions for collision avoidance. So what is collision avoidance? There are, for example, US Space Command, who has all over world telescopes or other tracking mechanisms to see space objects. And then they locate every space object and they track it. This information is then collected together. There are calculated collision probabilities on top of that. And then those information and data is sent out to the satellite operators. So if something is going to happen to your satellite, then you will get a note from them that, oh, there's a collision event coming up, do something. Of course, there's European Space Agency, who also gets some of their information from US Spacecom. They also have their own flight dynamics team, of course, who has information about their own satellites. So that's why they can provide information to other satellite operators in Europe, for example. And in addition to that, nowadays there are several private companies offering similar solutions. There are bigger ones like Leo Labs and Comspoc, but when, for example, a few weeks ago we went to Milan to a conference, we found out that there were loads of small companies actually either also building up their own telescope systems, even launching their own satellites to track other satellites in the orbit, and doing only the software, maybe only the tracking part, maybe both of them. So where do we fit in with our project? Basically, we use the knowledge of those algorithms. I'm not going to go into math. I'm just showing that there are several different algorithms to calculate the collision conjunction probabilities. And we are looking into them and see which one of those would be most suitable for our method. In ShareSat, our hope is that nowadays not all of the satellite operators actually share where they are in space, what are their trajectories, where are they maneuvering. It is assumed that they share it, and it is assumed that they share it very precisely. But unfortunately, it's not always the case. Sometimes they share some, let's say, probable trajectories. And that's why there is a cause that some of the satellites might collide. As you can see, I showed you that there are some close approaches. And because of that, we have developed software where you can calculate without actually sharing the data itself, the collision probabilities. Because sometimes, for example, if you have defense satellites, you don't want to share their location, but you still don't want to collide with other satellites, maybe some other defense satellite. So this solution would help to do that. How we do it? We use this kind of method called multi-party computation. It's one of the encryption methods where different space object tracking catalog providers, or there are space object owners, different parties, share their encrypted data to our ShareMind MPC, which calculates the probabilities on encrypted data and then shares the results back to the interested parties. For example, it can be just a risk assessment report. For example, in this project currently we are doing for European Space Agency, which started in January and going to end the mid of next year. We are currently only doing the calculation of the probability. Hopefully, we will get also the next part where we can actually send out the maneuver message also and calculate suggested maneuvers where this satellite should go to avoid collision, actually. So, probably some of you have heard that there are different similar methods of encryption. Multi-party computation isn't so famous, let's say it. Most of the famous one is probably homomorphic encryption, some of you have heard of. How does those methods compare regarding privacy, trust, and computational overhead between each other? Basically, the data privacy is quite similar compared to multi-party computation. The trust is actually not required in multi-party computation because there is no single trusted party required, which is much better. And when we compare the computational overhead, it is still, though high, it is not as high as using fully homomorphic encryption. So that's why this is actually the reason why we use multi-party computation for collision avoidance calculations, which is a fun thing. When we went to Milan to this conference, actually we saw that Akella, one of those collision avoidance original authors, probability calculation algorithm authors, was doing with his group calculations, similar calculations on fully homomorphic encryption. So it would be eventually, when they get out their results, a really interesting comparison how quickly they can do their calculations, and if we hopefully can do it much quicker and better. So how multi-party computation works? Does anybody, to be sure, how many of you have even heard about multi-party computation? 3, amazing. So I will start from the beginning. So basically there are, let's say, 2 persons who want to calculate some statistics on their data, but they don't want to share the data. But they still want to know the answer. So they take their data apart into 3 different parts. They send their data to some computation nodes that are outside somewhere. Those computation nodes shouldn't be connected to each other, because then, of course, you can put the data together. But those computation nodes can do the calculation separately and have 3 separate results. And then if those results are put together, then you will have actually the original result without knowing the original data. So just to keep you still interested in the object, I'm having, let's go over it, a short example how it is done mathematically. So let's assume we have 2 persons, A and B, with ages 25 and 33, and they want to calculate the sum of their ages without actually saying their ages to each other. So how they do it? They would choose randomly numbers. A chooses 57, 13, and then the last 3rd number has to be a modulo of 100, which is then the 55. The B chooses also 3 numbers, 44, 57, and then also a modulo 32 modulo 100. Those results then are sent to those 3 servers, as you can see. And each of those servers does those calculations separately. So basically, they take in, for example, the first server takes in 57, 44, and then calculates the sum of this, which is 101. So basically, 1 modulo 100. All the other servers, server 2 and server 3, are actually doing the same thing. As you can see, the servers actually don't get the original data. They don't see the 25 or the 33. They don't know anything about it. The data they get is, for them, completely random numbers. They can do, of course, the sum of this data they get, but they don't know why is it like necessary or what's the result. 1 modulo 100, 70 modulo 100, and 87 modulo 100 doesn't give any information to them. Now, when somebody wants to know the results, they send in those calculation results, and the output the user sees then adds those together and gets 58 modulo 100, which is actually the sum of those 2 ages. So, of course, this is a simplified explanation of the original idea, but it works the similar way in multi-party computation. So, what we do now is, in our ShareSat project, we have public catalogs, we could have private catalogs, mixed catalogs of different satellite trajectories. Those trajectories then can be secretly shared, as shown in the example, to 3, for example, different computing parties. All of those computing parties can be actually located also in those same catalog owners, but they can't collude between themselves, of course. And then when the calculations are done, the results are put together and then sent to the interested parties or interested party. For us, it means that we take in one of the trajectories, we divide it into 3 secret shares. Those shares go to different cloud servers, for example, which calculate the results, and then the results are put together. And this is what we have been doing. Of course, the project is still ongoing, so we don't have the precision results, we don't have calculation results yet. We have been comparing different collision avoidance algorithms and how they would be usable in this multi-party computation setting, because of course not all algorithms can be implemented, so we compare them. And currently we are implementing then this to our system and hoping that everything will work out. Thank you.
Thank you very much. Please sit down. I know that we are the ones who are standing between the networking and the bear I was promised. But bear with me a few questions before we leave. Thank you for the presentation. It was very interesting. I wanted to ask you the question what the previous presenters asked, that how concerned are you because of the cybersecurity situation in space domain? Is it something you're worried about? Is it enough handled, or how do you feel?
I think, of course, cybersecurity should be considered. Considering the company I work with, I think the answer that you have to consider it from the beginning, even starting with the passwords, is a good start. But if the company and everything is growing, then it should be always in your mind that one thing that you have to do. Because otherwise, if somebody takes over your satellite, it can do whatever. Even it can maybe destroy it, send it to drive into another satellite.
Yes, but from then arises a question: whose responsibility is it mainly? Is it should the cybersecurity threats be thought when the satellite builders have to think about it, or the service providers, or do the end users like telecommunication companies have to think about mostly on cyber?
I think everybody has somewhat to have to think about it, but definitely the operators who operate the satellites and offer the usage or the services of those satellites are the main users of the satellites, so they are the main person to think about it.
But if you think about the private and the public sector differences, is the main client for Cybernetica today rather public sector, or is it a private sector? If you think about specifically on cybersecurity, and the trends, is it going to change in the future somehow?
It depends a lot. As I said, for Cybernetica, there are so many different areas we work with. In some areas, of course, only the public sector is our client, because if we build governmental systems, then of course government is our main client. But for many other, for example, cybersecurity assessments and pen testing or something like that, there are our main clients, of course, private companies.
Are you handling the demand right now? As you are quite a fast-growing company, so are you handling right now the demand?
Actually, I'm not in the cybersecurity department, but as much as I have heard from them, actually they have more requests from different companies that they can handle, because sometimes, as I think at least, the companies notice that they need some kind of assessment quite late. Maybe some auditor tells them that, oh, you have have an audit coming up, where's your cybersecurity assessment? And then they are like, okay, I need it in a month.
So it often comes because of the audit.
I don't know,
so,
actually, I haven't heard about it, but it feels like it for me, looking from afar.
Then I also, again, make a connection with the last presenters about space education. Gen Z and attracting more talent. Your company is that kind of organization where mostly scientists and people from scientific background are working. You are heavily R&D company. How to attract talent and especially maybe to the cybersecurity, where to get your workflow?
Actually, I would say not Cybernetica, that's only this kind of scientific background, because of course I work in the research institute, there are researchers and students working in them, but in other departments there aren't specifically researchers working there. But attracting talent, Cybernetica has heavily invested in education. For example, teaching in universities is the best way to connect with the younger generation.
So there you have your question, answer to your question that was asked before, that how to attract new talent to go and teach at the university and get the better minds from there directly. Well, I actually really want to refer also to the astronaut competition. It was really a good example how to young people get more to the more interest to the space domain.
And it doesn't mean that you have to attract to your company. Actually, sharing your knowledge increases the domain generally, which is good.
Last question that I have to you is not cyber security related, but as I know that there are several companies in the audience that it is not easy to get ESA contract. So as mentioned also, it was quite a long process for you too. Maybe you can comment what is the, how did you reach that success, and what was the most difficult part in this process?
As already said, the process was almost, let's say, 10 years or something. I haven't been there from the beginning, so I don't know so much about the starting points. Of course, we had the original project, and we wanted to continue for the next phase, have the real data to do the calculations and see if that actually works, the collision avoidance calculations. But back then, when we pitched the idea to European Space Agency, as I have heard, they said that start from easier projects. This is maybe too big projects for you if you haven't done an ESA project before. So let's think about some other easier project beforehand, and then you can pitch us again when you have showed yourself to us and know how to do the general projects. So it wasn't our first project we did. That's why we did other cybersecurity related projects beforehand. And then finally, I think our proposal writing period from the start of the proposal writing to the end or to the start of the project was, I think, 2.5 years. Because the project proposal was sent between and back from ESA to us for corrections and so on.
But thank you. I hope you will stay for the networking event too, so you can ask more questions. Our time is up, and thank you for our presentation, and good luck with the project, and hopefully big results will come out of it. Thank you very much.
Thank you.